Good afternoon. Today we shall discuss about the band theory in metal or band theory in solid. Many times this question arises that what is the metallic bond? We have ionic bond, covalent bond, and bonding between metal and metal atom is the metallic bond. So, how we can explain? Here, this is the definition. Metallic bond is defined as force which binds mobile electrons with kernel of the metal atom. What is kernel? Kernel of the metal atom is nothing but the charged metal atom. Yeah, metal ion you can say. This is the metal ion. This is metal ion. Because these electrons of each metal, they are mobile. It can move from here to here, it can move from here. So all these electrons can move. In other words, we can say that it looks like electron C in which positive metal ions are dropped. And in this way, there is a force of attraction between the electron cloud, mobile electron cloud, and the kernel of the atom. But this theory is not very successful. We cannot explain so many characteristics of the metal. Why metal is a good conductor of heat and electricity? Why there is malleable character of the metal? Why metals are tactile? So these characters cannot be explained with the help of this theory. So later on, the molecular orbital theory can explain the bonding in the metal. What is the difference between diatomic molecular orbital and the multi-atomic molecular orbital? No difference. Only dimension of the molecular orbital is changed. Suppose there is a one atom, this is one atom, electron, so it forms molecular orbital like this. If there are three atoms, one, this one, so molecular orbital will be like this, So molecular orbital dimension is increased. In this way, it has been assumed that in case of metal, multi-nuclear molecular orbitals are formed. And that can be explained with the help of molecular orbital theory. We know that when two atomic orbitals linearly combine with each other, so we shall get bonding molecular orbital and anti-bonding molecular orbital. Bonding molecular orbital sigma, anti-bonding molecular orbital sigma star. Bonding molecular orbital may be pi, anti-bonding molecular orbital will be pi star. can explain the formation of the molecular orbital in case of metal. Let us consider that there are n atoms in the metal. N atoms in the metal. Example, lithium metal. Lithium metal. Let total number of metal atoms equal to capital N. So out of N atom, bonding will be N and anti-bonding will be also N. So number of bonding molecular orbital will be equal to capital N, and number of anti-bonding molecular orbital will be N also. So all electrons will be distributed in bonding and anti-bonding molecular orbital. Non-bonding molecular orbital is also formed, and we shall explain all this by diagram. Let there is a one atom, this is another lithium atom, one electron. There is one electron, valence electron, you know. This is the electronic configuration of lithium 1s2, 2s1. So this is the valence electron. So there is one electron in valence shell of the lithium atom, and this is one electron. So when these two atomic orbitals combine together linearly, we shall get molecular orbital like this. This is the bonding molecular orbital, and this is the anti-bonding molecular orbital. How many electrons? One electron in this atomic orbital, one electron in this atomic orbital. So there are two electrons in the bonding molecular orbital. Now suppose there are three atoms. We are considering three lithium atoms to form the molecular orbital. So how? One lithium, one electron in valence shell, second lithium, one electron, third lithium, one electron, lithium, and it will be like this. This is the bonding molecular orbital. This is the non-bonding, and this is the anti-bonding. So there are three electrons. Two electrons will enter in the bonding molecular orbital, but one electron is that it will enter into the non-bonding molecular orbital. But let us consider four atoms, one electron, and one electron, like this. Lithium, orbital and these two are anti-bonding molecular orbital. 4 electrons, 2 electrons in this plate and 4 electrons, all 4 electrons are in bonding molecular orbital. So suppose there are n atoms, in one mole of the substance there are 10 to power 3 number of the atoms, that is the Avogadro number, 6.02 into 10 power 23. So this is the very big number. So how all big numbers make a molecular orbital? Of course, molecular orbital will be formed according to this system. Now, when there is a huge number of the molecular orbital, certainly spacing will be very small. If the spacing between, this is the spacing, difference of the energy between these one, this is the spacing. If there is a huge number of the molecular orbital of order 10 power 23, just see all molecular orbital, whether it is bonding or it is anti-bonding. They are closely spaced, and when all molecular orbitals are closely spaced, that looks like a band. That looks like a band. How we see the band? Just see that here 1, 2, 3, 4, 5, n. One electron in the valency set, 1 electron, lithium, like this. So what will be the band formation like this? Molecular orbitals which are filled, they are closely spaced and form a band. So this band is known as valency band. Valency band. And it is filled. It is filled. But what about this band? This band. It is the conduction band. Conduction band. So conduction band is empty. ये भरा हुआ. So just see, in case of lithium, there is no gap between the conduction band and valency band, and therefore it behaves as a good conductor. Almost in all metals, conduction band is just above the valency band. So you can say the filled upper part of the valency band is near to conduction band. If there is no, suppose in case of band formation, there is a gap between conduction band and valency band. So this can be also explained in this way. Suppose this is the conduction band and this is the valency band. This is the valency band. This band is filled like this. There is a difference of energy. Difference valency band. So there is a difference, but the difference is very, very small. Very, very small difference. In some case, you will find that conduction band may overlap. Conduction band may overlap like this to valency band. Valency. This is the valency band and this is the conduction band. This band overlap upon the valency band. Conduction band and this is the valency band. So in case of metal, difference of energy which is known as forbidden zone. Forbidden zone. Just see in case of insulator, suppose this is the conduction band and this is the valency band like this. This is the valency band. Valency band, this is the conduction band. So in this is the delta. Sometimes you can say it is the EG. It is the forbidden zone. Forbidden zone. Forbidden zone. And the energy is the forbidden energy. So this energy is more than 3 electron volt. So material will be insulator. So this is the insulator. But if the energy gap between conduction band and valency band is between 0.67 electron volt to 3 electron volt. You can also say from 1 electron volt to 3 electron volt in between. So material will be semiconductor. So here you can say this is the semiconductor. Conduction band, valency band, and EG it is equal to 1 electron volt, 1 electron volt to, you can write like this, 0.67 electron volt to 1.06 electron volt like this. So it is the semiconductor. This energy level. So in this way, we can explain how molecular orbital is formed in the metal and how closely spaced, large number of the closely spaced molecular orbitals are band like this. This is the valency band which is filled. Sometimes it may be partially filled, but this band. Now just see how conduction of electricity takes place. So you can explain, suppose that there is a conduction band like this. This is the conduction band and this is the valency band. This is the electron. Here, electron, like this. So if the energy gap is very small, what will happen? A small energy, even at room temperature, this electron can jump to this. And if the electron moves to create a hole, positive hole. You will get, suppose this electron has been transferred to the conduction band, where we apply some electric field. So this will be a hole, like this. This will be a hole. This hole may also move. So flow of electricity is not only because of the flow of the electron, the flow of electricity is also because of the moving positive hole. In this way, we can explain the conductance of the metal, character of the metal. Now, second thing, what is the effect of temperature on conductance of the electricity in the metal? Probably you know that conductance of the metal decreases with increase of the temperature. So how we can represent? You can show, yes, I can say effect of temperature or conductance. So let us consider here it is the conductance like this. Here temperature T, you can say 60, 80, like this. Kelvin. So in case of metal, you will find that this is the change of temperature for metal. It is shown that temperature gradually decreases with increase of the temperature. It is the metal. But in case of semiconductor, it is just reverse. In case of semiconductor, conductance increases with increase of the temperature, and you can represent it like this. Like this. This is the semiconductor. Semiconductor. So in this way, you can also explain the conductance, effect of temperature on conductance. Now, I would like to explain the formation of band in another way also. So just see here, there is a sigma 1s molecular orbital. It may split into bonding and anti-bonding. So this is suppose it is the anti-bonding, like this. Anti-bonding. And this is another sigma 2s. It has one and it has another. This molecular orbital, one is the bonding of lower energy, another is the anti-bonding. So just see, you can split like this, you can split like this. So this band, this is the valency band, and this is the conduction band. Similarly, you can also explain the formation of the band when p atomic orbital, which combine to form the molecular orbital. Suppose sigma pz. So sigma pz will also split into sigma star pz and sigma pz, one bonding and anti-bonding. Always you know that there is a increase of energy like this. This is the bonding here, bonding takes place. It is the bonding molecular orbital and it is the anti-bonding molecular orbital. Already you know this is the anti-bonding molecular orbital and this is the bonding molecular orbital. And mathematically you say this is the molecular orbital psi a square plus psi b square plus 2 psi a psi b. Here it is psi square mo, it is equal to psi a square plus psi b square minus 2 psi a psi b. So this is the splitting. Exactly I say here. Suppose in case of lithium 1s2, 2s2, 2s1. So all 1s atomic orbital of all metal atoms in one mole, suppose in one mole. So all will form molecular orbital known as sigma 1s. This is the molecular orbital. And this molecular orbital is of two types. It is the anti-bonding higher energy. It is the bonding lower energy. So in this way, you find that a huge number of, here they put sigma 2s, it is the molecular orbital formed by the combination of 2s atomic orbital. How many molecular orbital will be formed? Two molecular orbital. One is the bonding, second is the anti-bonding. This is the anti-bonding. This is the bonding of this. This is the anti-bonding. This is the bonding. In this way, ultimately you find that the bonding of these, they become very close to each other, and in this way we get a closely spaced band of large number of the molecular orbital, and forming the band as I explained. Here this is the one band, this is the completely filled. Here two electrons like this. Here maybe two electrons or may not be two electrons, but no electron. You might be no electron. So in this way, this band is completely empty, this band is completely filled, and here this is the conduction band, this is the conduction band formed by the anti-bonding molecular orbital, this is the valency band. In this way, you can explain the band theory in the metal, means how metal bond is formed in the light of the band theory. Thank you.